turned to pot. And then I was like, oh, today's supposed to be mostly sunny. And now we've got this garbage. So I'm just going to see. We're going to just kind of set this here and watch it in real time. And so what we're going to do while we watch it in real time is we're going to actually show some things through um, measurements, and we're going to test the model basically. Um, I'm going to kind of get some of this. So I'm trying to do a new one for today. Hey, you actually can hear the birds and everything outside. That's pretty cool. So we've already did one measurement. I was able to snag a snapshot from this morning. And we're going to look at that real quick. This is the screenshot from today at 10:20 and the position of the shadow. So we can do two things with this. We can measure and get the azimuth position of the sun, and we can also measure the shadow length and get the elevation angle of the sun. So for anybody out there that's really interested in learning how to do this, you can do this yourself, and you can locate the sun in the sky through just this one little device here. Now you got to remember the most important thing when you do this observation is to make sure that you are aligning to true north or true south, whichever one. That straight line, that you're aligning to that when you take these measurements, and not off your compass. Your compass has a magnetic declination, and it may not be accurate. And when we're talking about trying to measure down to the degree, we want to be as accurate as possible. Now you got to remember this is also an analog instrument, it's not digital. So there is going to be a little bit of variance in accuracy. It's going to be accurate, but it's not going to be as accurate as a digital instrument. But you can easily do this. And while we're waiting on the sun to pop its head out, which looks like we got some good sun right here. We can actually look at what this measurement is going to be at according to the globe model. So right now it's 1055, and so let's see what 1055 is supposed to be on the globe model. Right now 1055, according to all the models, the globe models, at 1055 we're going to get a 155 degree azimuth heading. So 155-degree azimuth, so we have to look at that image that's in the screen and see what 155 is. So we can do some simple math here, and we can just do what's 180 minus 155, and we're going to get a number of 25. So each of these little ticks on this declination dial is 5 degrees. So if you go off of the solar noon, the top part, you just go off 5 degrees. So you're at the very top, and then you go 1, 2, 3, 4, 5. Okay, so 5 marks off of the solar noon mark, which is 5, 10, 15, 5, 10, 15, 20, 25. So it is hitting at the 155 marker, or if you want to do if you do 360, you can do it this way: 360 minus 25 equals 335 degrees. So 335 degrees is where the shadow is. So the shadow is going to always be 180 degrees off of where the sun is. So you can do your 335 and you can minus 180, and that gives you your 155 degree azimuth. So